Okay, so the same kind of concept that we just finished, we're going to look at equations with 3 variables and how to solve those. But the methods are going to be the same thing that we just finished. But I don't think I have to probably tell you that with 3 variables, it's a little more lengthy. And there are more steps / more opportunities for you to make those sign errors and forgetting to multiply through by the same number and all that kind of stuff. So whatever issues you had with 2 variable systems, just know that with 3 variable systems, it usually amplifies those up quite a bit. So I'm going to show you kind of one of the methods we use in a minute, but let's just talk about what a 3 variable solution looks like. Notice instead of 2 numbers in the parentheses, it's how many? 3. Okay, so we usually call these numbers x, y, and z. So this is going to be your x, your y, followed by your z. You're going to see me do my z's like that so that they don't look awfully close to 2's, so you need to do something like that. So let's look at a 3 variable system. With a 3 variable system, because there are 3 variables, we will often, not always, but often have 3 equations. So just like with 2 variable systems, what's going to have to be true about this 2, 3, 3 number? It's going to have to work for how many of those equations? The answer is it's got to work for all of them. Okay, so I'm going to try to do this kind of a little briefer than I did before. So the question here is 2 plus 3 plus 2 times 3 equal to 11? Okay, so notice what I did. I plugged in 2 here, 3 here, 3 here. Okay, so let's just briefly do that, right? 2 times 3 is 6. So 2 plus 3 plus 6 equals 11. That's a yes. Okay, that works. So let's check the second one, because for it to be a solution, it's going to have to work for all of them. So is 2 plus 3 times 3 equal to 14? So notice, all I'm doing is taking this second equation and plugging in 2, 3, and 3. So I get 3 times 3, which is 9, plus 2 plus 3. So that works also. So lastly, let's check the last one. Is 2 plus 2 times 3 minus 3 equal to 5? So notice I'm using this equation this time, right? So 2 times 3 is 6, 2 plus 6 is 8, minus 3 is 5. That one works too. So the fact that it works for all 3 means what for our final answer? Yes, it's a solution, right? So for something to be a solution / to work, it's going to have to be a solution for all of them, just like it was for 2 variables. So if you skated through the 2 variable systems, I just want you to take a pause and make sure you understand the concept enough to switch it to 3 variables now. So the steps for solving a 3 variable system, I'm going to use the addition method. I do the addition method because it's usually the preferred method of the 2 I already taught you anyway. Okay, but it is more tedious. There is more work to do. So let's go through the steps and then we're going to practice on a few. So first you need to reduce 2 different pairs of equations to the same 2 variables. In other words, you're going to pair up 2 equations, 2 sets of 2 equations actually, and you're going to eliminate 1 variable. You started off with 3, and you're going to kind of whittle it down to 1. So step number 2 is now you're going to have 2 equations that you just worked to combine. So now you're going to combine these two equations together. And by the way, remember, both of these equations only have two variables now. And we'll use the addition method again and solve. And then step number 3 is you're going to plug in the two known values that you now know from step number 2. So you're going to plug in the two known values to any equation to get the third value. And then last but not least, you're going to write your answer as a point and check it. So if you feel like we're kind of being redundant here, it's because the last couple steps in all of these methods really are the same. Like once you know some of the information, you use the known information to figure out what you don't know. Okay, so I'm going to be honest with you. I don't think this is hard, okay, but it does get tedious. I call them tree killer problems. It takes a little bit of time. It takes a little effort. It definitely takes you having some organization and keeping your facts straight, okay? Sign issues are even more of a problem here on equations like this. So just kind of keep that in mind. Keep that information in your back pocket so that you don't move too hastily and make little sign errors that you'll be angry at yourself for later. So let's say that I have these three equations. X plus 2y minus 3z equals 9. 2x minus y plus 2z equals negative 8. And negative x plus 3y minus 4z equals 15. Okay, so the first step is in your mind or write it down, I don't really care, okay? You need to choose which variable you're going to eliminate first. So you can get lost in the steps of this problem because it is lengthy, okay? So choose which variable to eliminate first. It doesn't matter which one, so you just want to pick the one that looks the smallest / the easiest to eliminate, okay? So I'm going to choose here we will choose x first. So remember, your ultimate goal is to try to see if you can eliminate x. And you're going to do that by comparing or combining two different pairs of solutions together. Okay, keeping in mind that your goal is to eliminate x. So look at the first and third equations. What do you already notice about x? That's actually the reason I picked x. If you just line up the first and the third equations, what's already going to happen? Yeah, the x's are going to get eliminated, right? So that'll be the first half of the first step. So notice I don't even have to do any work, right? That's already going to happen. And then I'm going to get 5y minus 7z equals 24. Okay, so I'm going to hold on to that because I'm not really quite ready to work on it yet. So now I need to do this again. Okay, you can combine another pair of equations together and you're still going to try to get rid of x. Okay, so I'm going to combine the second and third equations together. But you just as easily could have done the first and second together. The only reason I decided to do second and third together is because one of them was already positive and one of them was already negative. But notice I'm not ready to combine these yet. How come? Is x going to get eliminated if I do it like it is? No, right? Because 2 minus 1 is still there, right? So what do I need to multiply the second equation by so that I can do it like I want? 2, right? Remember my goal is still to eliminate x. So I'm going to get 2x minus y plus 2z equals negative 8. Nothing changed on the first equation. And then negative 2x minus 6y minus 8z equals 30. Notice everything got doubled, right? Not just the first term. So now when I combine these together, the x term's going to go away, and I'm going to get negative 7y minus 6z equals 22. So I'm going to circle what I got here in step 1. Now I have two equations, right, that only have how many variables? How many variables are there in these two equations? 2, right? Y and z. They're both the same variables. So now what I'm going to do is I'm going to combine these together. Okay, because they have matched up variables. So now I'm going to try to combine those up. So I'm going to ignore all the mess that I just did, and I'm just going to line up 5y minus 7z equals 24. And I'm going to line that up with negative 7y minus 6z equals 22. So note the numbers are kind of large, but that's okay. So we just need to keep our details straight. So what I'd really like, and actually, I made a mistake, and I want y'all to try to tell me where it is. And I did not do it on purpose, okay? But I made a sign error way back here, and we need to fix it before we move on, okay? So I told you sign errors were common. Even I just made one. So can y'all see the sign error? It's in this area. So I was supposed to be doubling everything, right? But what did I do? I did 2 times 3, and I said it was what? Negative 6, and I don't even know why I did that, right? It shouldn't have been negative 6. It should have been what? Positive 6, which means that this should be a 6, right? And this should be a 5. So I made a sign error note, not on purpose. That just happens sometimes. And sometimes you just copy the number down wrong, and you just make goofy errors like that. So you want to try to avoid doing what I just did there, okay? But now let's see if we can combine these together, right? So what do you notice would be really nice to have, and then y would get eliminated? Yeah, if like one of them was negative 5, then we'd be good to go, right? So it doesn't really matter which one you choose, but I'm going to choose this one. So I'm going to multiply this by negative 1. Note that's going to give me 5y minus 7z equals 24. And negative 5y plus 6z equals negative 22. So let's see if I can get through this problem without making another sign error. Okay, so now the y's are gone. So now I get, watch your signs, negative z equals 2. But I don't really want negative z. What do I actually want? Regular old z, right? So I'll divide by negative 1. So I get z equals negative 2. So I'm going to go ahead and circle that. But that's only a third of my answer, right? What do I still have to know? I still have to figure out what? I know z, but I still want to find x and y, right? So now I'm going to go back and find y using one of these two equations. So now I'm going to find y by plugging in z equals negative 2. So if I do the first one, 5 times y minus 7 times negative 2 equals 24. So be careful with your signs. This would be positive 14, right? And then I would subtract 14 from both sides. So this will be 5y equals 10. So what is y then? Y is 2. So now we're 2/3 of the way. So now we just need to find what final thing? We just need to find what last thing? Find x, right? So we just need to find x by plugging in the two things we know already. So we're going to plug in y equals 2 and z equals negative 2. And it doesn't matter which equation I use, okay? So I'm just going to take the first one, for instance. So x plus y plus, x plus 2y I'm just taking the first equation in my list. X plus 2y minus 3z equals 9. So that's going to give me x plus 2 times 2, because y is 2, minus 3 times negative 2, because z is negative 2. So I end up getting 4 plus 6, or 10. And then I can subtract 10 from both sides. And so I end up getting x equals negative 1. Okay, so how do I need to write my solution then? I've got all three of them now. So what do I do now? Yeah, write them as a point. Okay, so make sure you do x, y, z order. So negative 1, comma 2, comma negative 2. Okay, and what's the last part of the final step that I want you to do? Check it. Okay, it's a little bit of a pain in the butt to check it, but you can know that you're right. So I'm going to slide this back up, okay, and I'll move it out of the way in a minute. So what I mean by check it is literally plug in negative 1, 2, and negative 2 every time and see if you get the answer that you're supposed to get. Okay. So with more steps, there's certainly more opportunity for making a mistake. So let me just show you real quick on the calculator what your check step can look like, and then we'll talk about what we're going to do next time. So here's the first equation, right? So if you don't have a calculator, you need to be looking up here. So negative 1 plus 2 times 2 minus 3 times negative 2 is supposed to be 9, and it is. Okay, and we can check the next one. 2 times negative 1, so now I'm looking at this equation. Minus 2 plus 2 times negative 2 is supposed to be negative 8. Made an error because I put a double time sign. And notice I get it there, right? And then finally, negative 1, right? So I could even do that if I want to. Negative 1 plus 3 times 2 minus 4 times negative 2. And notice I get 15 just like I thought. Okay, so check it, take a couple extra seconds to check it, and you can see if you did it right. Okay, so we're going to start next class with questions like this, but I just want to, before I let you go, I want to talk about what do you do if you know you're making a mistake because you're checking it and you can't figure out where it is. Okay, my strong suggestion for you is to take a couple seconds and try to find out if you made a sign error. Do you think it's going to be kind of hard to find your error sometimes? Yes, okay, so my strong suggestion is if you've looked at it for about a minute and you can't find out where your error is, scrap it and start over. And maybe even eliminate a different variable first this time. Okay, like change up what you're doing, because otherwise you can get really frustrated and just stuck on the same question over and over and over, and that's not what I want when y'all are doing your homework. So that's my strong suggestion. If you can't find your error pretty immediately, then scratch it and start over and maybe get rid of y first instead of x if that's what you're doing. Okay.